When we hear the phrase speed of light, most people instinctively think of it as just a very large number, 300,000 kilometers per second, an impressive record set by nature, like the fastest animal or the tallest mountain. But that intuition is deeply misleading. The speed of light isn't simply something that light happens to do very well. It is something the universe is built around. And this is where Richard Feynman's way of thinking quietly pulls the rug out from under your common sense. Imagine you're standing still and you turn on a flashlight. Light moves away from you at the speed of light. Fine, now imagine you're moving toward that light source at half the speed of light. You might expect the light to move away from you faster. Speed plus speed, simple addition. That's how every other experience in your life works, but nature refuses to cooperate. You still measure the light moving away from you at exactly the same speed. Push harder. Move at 90% of the speed of light. Same result. From your perspective, light stubbornly refuses to go any faster. At this point, Feynman would pause and let the discomfort sink in, because discomfort is the signal that your intuition has failed. The universe is telling you that your everyday logic, the logic built from throwing balls and driving cars, does not apply at the foundation of reality. Something deeper is going on. The shocking conclusion is not that light is special because it's fast. The shocking conclusion is that space and time are special because they adjust themselves to keep light's speed the same for everyone. That's the reversal that collapses the mind. Time slows down, lengths contract, clocks tick differently depending on how fast they move. Not because nature is being dramatic, but because it has no other choice. If time and space did not bend, the speed of light would not remain constant, and the universe seems unwilling to let that happen. This is where Feynman's brilliance shines. He didn't treat this as mystical or poetic. He treated it as a brutally simple fact. Experiments say light speed is invariant, and therefore the universe must obey that rule, no matter how strange the consequences. Reality doesn't care if we find it confusing. It only cares about being consistent. And psychologically, this is a devastating idea. We like to believe we move through space and time as fixed backgrounds, like actors on a stage. Feynman helped us see that the stage itself flexes beneath our feet. Space and time are not passive containers. They are active participants responding to motion, protecting a deeper rule. That deeper rule is not about light itself, it's about information. Light represents the fastest way information can travel, the fastest way cause can influence effect. If that speed were different for different observers, the universe would lose its logical structure. Events could happen before their causes. Agreement about what now means would dissolve. Reality would become internally inconsistent. So when we say the speed of light is the limit, we're not saying, sorry, you can't go faster. We're saying, this is the speed at which the universe can remain sane. The limit exists not to frustrate us, but to preserve order. Feynman often emphasized that nature is economical. It doesn't add rules unless it must. The constancy of the speed of light is not an extra rule pasted onto physics. It's a structural beam holding everything else up. Once you accept that, the strange effects of relativity stop feeling like bugs and start feeling like necessary features. And notice something subtle but profound. Light doesn't experience time at all. From the perspective of a photon, if such a perspective could exist, emission and absorption happen instantaneously. No duration, no journey, that alone should unsettle you. The ultimate speed in the universe is also the speed at which time disappears. That is not an accident, that is a clue. What Feynman uncovered and what many people still miss is that the speed of light is not the universe's fastest runner. It is the universe's rulebook written into motion. Break that speed, and you don't just outrun light. You unravel the meaning of space-time and cause itself. Once you accept that the speed of light is not negotiable, the universe reveals its next move, and this is where things stop being merely strange and start becoming deeply unsettling. Because if light speed cannot change, then something else must. And what gives way is not light, not energy, not the laws of physics, but time itself. This is the point where most people quietly check out because time feels sacred. We build our entire psychological life around it. Past, present, future, cause, then effect, a steady flow, ticking forward like a cosmic clock. But Feynman had no patience for sacred illusions. If the equations say time bends, then time bends. Your feelings about it are irrelevant. Imagine trying to chase a beam of light. The faster you go, the closer you get to that ultimate speed. But instead of letting you catch up, the universe starts changing the rules behind your back. Your clock slows down relative to everyone else's. Processes inside you, chemical reactions, biological rhythms, even thought itself, begin to stretch. From your perspective, nothing feels wrong. Your heart beats normally, your thoughts feel ordinary, but to someone watching you from the outside, you're moving through time more slowly. This isn't science fiction, this isn't metaphor, this is experimentally confirmed reality. Atomic clocks flown on fast airplanes tick more slowly than those left on the ground. Satellites must correct for this effect or GPS would fail within hours. Time dilation is not philosophical speculation, it's engineering. And here's the uncomfortable psychological punchline. Time is not universal. There is no single now that the entire universe agrees on. Two people moving differently through space do not share the same present. Feynman loved this result because it demolishes the idea that human intuition is a reliable guide to fundamental truth. We evolved to survive, not to understand the structure of space-time. As speed increases, something else happens. Length contracts. Objects moving close to the speed of light become shorter in the direction of motion. Again, not because of mechanical squeezing, but because space itself is remeasured. The universe is rearranging its geometry to protect the one thing it refuses to compromise on, light speed. And then there's mass, or more precisely, inertia. The faster an object moves, the harder it becomes to accelerate. It resists change more strongly. Feynman would explain this not as mass increasing, in a naive sense, but as energy piling up into motion itself. You're not adding speed anymore, you're feeding energy into the structure of spacetime. Eventually, the resistance becomes overwhelming. This is the key realization. The universe does not block you at light speed with a wall. There is no cosmic police officer saying stop. Instead, reality makes every step forward cost more than the last. Energy requirements explode. Time distorts. Space reshapes. The closer you get, the more violently the universe protects the limit. Philosophically, this is profound. The universe doesn't enforce its rules through force. It enforces them through consequence. Try to outrun light, and reality doesn't punish you. It simply stops cooperating. Feynman understood that this wasn't about motion, it was about consistency. If time did not slow down, if lengths did not contract, then observers would disagree on cause and effect. One person could see an event happen before its cause. The logical order of the universe would fracture. So time bends not as a dramatic flourish, but as damage control, and this should bother you in a productive way. Because it means time is not the deep, unshakable foundation we imagined. It is flexible, conditional, responsive. It behaves less like a river and more like a material stretchable, compressible, shaped by motion and energy. This forces a psychological shift. If time itself can slow, then urgency is relative. Progress is contextual. Even the idea of moving forward becomes slippery. Feynman's quiet lesson here is humility. The universe does not organize itself around human expectations. It organizes itself around coherence. So when people ask why nothing with mass can reach the speed of light, the answer is not because it's forbidden. The answer is because time breaks first. Reality would rather distort your experience of duration than allow a contradiction at its core. By the time you've accepted that space and time will twist themselves into knots to preserve the speed of light, you might reasonably ask the next question, fine, but what actually stops us? What is the final barrier? And this is where the universe delivers its most unforgiving answer. The wall is not speed. The wall is energy, and that wall doesn't just rise. It goes straight to infinity. Feynman loved problems like this because they look innocent at first. Take something with mass, a particle, a spaceship, a grain of dust, and start pushing it. You add energy, it goes faster. That's how life works. That's how we're wired to think. But as you push closer and closer to the speed of light, the relationship between energy and speed breaks away from intuition. You can keep adding energy, enormous amounts of it, but the speed increase becomes smaller and smaller. The object doesn't refuse to accelerate, it just gives you less in return each time. This is not because the object is being stubborn. It's because energy is no longer going into speed in the way you expect. It's being absorbed into the structure of motion itself. Feynman would say that you're not just moving the object through space anymore, you're pushing against space-time. Here's the brutal simplicity of it. To reach the speed of light, an object with mass would require infinite energy. Not a lot of energy, not an unimaginably large power source. Infinite, and infinity is not a technical challenge. It's a declaration of impossibility. This is where physics becomes quietly philosophical. Infinity is nature's way of saying, this path does not exist. When equations produce infinity, it's not an invitation, it's a stop sign. You don't solve infinity with better engineering. You don't outsmart it with clever design. You turn around and ask what assumption led you there in the first place. What assumption fails here? The assumption that you can keep converting energy into speed forever. That assumption works at low speeds. It works in daily life. It even works in most of engineering. But near light speed, the universe reveals that energy and motion are fundamentally different things than we imagined. Feynman emphasized that mass and energy are not separate categories. Mass is a form of energy. Motion is a form of energy. And as speed increases, energy piles up not as velocity, but as resistance to further change. The object becomes harder and harder to push, not because it's heavier in your hands, but because the universe is charging you a higher and higher price for consistency. And this price has psychological consequences for how we think about limits. We like to believe limits are arbitrary, set by rules, authorities, or lack of resources. But this limit is intrinsic. There is no workaround because the cost function itself diverges. The closer you get, the faster the price climbs. At the limit, the price is infinite. Notice something elegant here. The universe does not say, you may not. It says, you may try, but you will never finish. That's a very different kind of prohibition. It preserves freedom while guaranteeing impossibility. Feynman would point out that this is the same pattern we see elsewhere in physics. Absolute zero temperature cannot be reached. Perfect efficiency cannot be achieved, not because they're illegal, but because the steps required never end. Nature enforces its deepest rules not with fences, but with asymptotes, and this has a deeper implication. Light itself has no mass. That's why it can travel at light speed. It doesn't need infinite energy to do so. It simply exists in that state. The limit is not about light being special, it's about mass being costly. The moment you have mass, you have inertia, and inertia is the universe's memory of energy already spent. So when people dream of faster than light travel, what they're really dreaming of is a way to cheat energy, to get motion without paying its full price. Physics has no evidence that such a loophole exists. Every experiment we've ever done suggests the bill always comes due. And here's the philosophical sting. The universe is not hostile to ambition. It's indifferent. It doesn't stop you out of cruelty or kindness. It simply keeps its books balanced. Conservation of energy is not a moral rule, it's an accounting rule. So, the real lesson isn't that light speed is unreachable. The lesson is that reality is coherent all the way down. You cannot demand a result without supplying what it costs, not in physics, not anywhere. By the time you reach this point, something important should feel different. We started with a simple question about speed, and somehow we ended up questioning time, energy, and the structure of reality itself. That's not an accident. Feynman understood that the deepest truths in physics don't live in complicated formulas. They live in the consequences those formulas force on the universe. And the final consequence of the speed of light is not technical at all. It's logical. At its core, the speed of light is not about light. It's about causality. It's about the rule that causes must come before effects. That sounds obvious, almost childish, but it turns out to be one of the most fragile assumptions in existence. If information could travel faster than light, that assumption would collapse instantly. Here's the uncomfortable part. Faster than light communication doesn't just mean faster spaceships or better technology. It means that, for some observers, an effect could be seen before its cause. Not metaphorically, literally, a message could arrive before it was sent. A decision could be observed before it was made. The order of events would depend on who is watching and how they are moving. Feynman loved pointing out that physics doesn't care about your comfort. It cares about consistency. If two observers can't agree on which event caused the other, then the universe loses its ability to define what cause even means. Logic fractures. Prediction becomes meaningless. Science itself stops working. This is why the speed of light isn't negotiable. It's not a speed limit imposed from the outside. It's a structural rule holding reality together from the inside. The universe is not saying nothing may go faster. It's saying nothing may break the order of cause and effect. And this explains something subtle that often gets missed. Relativity doesn't destroy causality, it protects it. Time dilation, length contraction, infinite energy requirements, all of these strange effects exist for one reason: to make sure that every observer agrees on what can influence what. Reality is willing to sacrifice our intuition, our sense of simultaneity, even our experience of time itself, but it will not sacrifice causality. Feynman saw this as a kind of ruthless elegance. The universe enforces its deepest rule with astonishing efficiency. It doesn't need extra mechanisms, it doesn't need patches. One constant, the speed of light, does all the work. Everything else falls into place around it. Think about how radical that is. The universe allows countless possibilities. Galaxies collide, stars explode, particles appear and vanish from empty space. But there is one thing it refuses to allow: a contradiction. Nature will tolerate violence, chaos, and uncertainty, but not inconsistency. And there's a philosophical mirror here that's hard to ignore. Human minds are excellent at inventing stories that feel true but aren't consistent. We hold contradictory beliefs. We excuse logical breaks when they're convenient. Reality does not have that luxury. It must balance every equation, every interaction, every consequence. Feynman often warned against the temptation to explain away hard truths with comforting language. Faster than light ideas are attractive because they promise escape from distance, from delay, from limitation. But physics is reminding us that limits are not always obstacles. Sometimes they are the framework that makes meaning possible at all. Without the speed of light as a limit, there is no shared reality, no universal agreement on events, no stable notion of before and after. The world dissolves into a collection of disconnected perspectives with no common story tying them together. So when people say, "What if we could break the light speed limit?" they're really asking, what if reality didn't have to make sense? And Feynman's answer, whether spoken or implied, is simple: then it wouldn't be reality anymore. The deepest thing Feynman uncovered wasn't a new particle or a clever equation. It was this: the universe is not designed to satisfy our desires. It is designed to remain coherent. Every law of physics is, at some level, a defense against contradiction.